Hey, welcome back. This will be episode 4 now. Last episode on number 3, I showed kind of what coordinate systems were all about, how to rotate a point, what 6 degrees of freedom were, things like that. So if you don't know that or missed the video, go back and check that out. So I'm going to show you the different types of moves that we can do here on the robot. So, or at least a couple of the useful ones. So what I need in order to do a move is another target. So what I can do is just copy this target, paste him in, and I'm going to grab him and just move him. We'll move him up above this controller here, and I can go switch over to world. Sort of see with this is where the 3D mouse really comes in handy to sort of drag things around. Normally you'd be creating these points off of some sort of CAD geometry or something like that, but we're not going to do that yet. So there's my 3 points. Let's go ahead and get him and move him down just so we can really see what's going on here. And this controller is a nice piece of reference, I guess. Move him back out of the way though. So I've got my 3 points now. So they're called target 10, and it just gives you extra names here. So I'm going to go ahead and fix these. Typically, it helps you if you want to keep them in order. It's much nicer. And 1, 2, 3, and then we skip by 10, or it skips by 10 by default. I think you can change that in the options, but I skip by 10 just due to their standard, but it lets you go and poke one in later on. You can always rename them in a semi-automated fashion, so that's nice. But let's move on. Get all 10 of them, all 3 of these paths here, and do right-click on them, add to new path. And so that's taken the points and it's actually added them to a path here. What's interesting about this that took me a little while to figure out, and I left this out in the IDE tour, is that it uses these parameters down here. So we're doing a move linear, and we're doing a velocity of 1,000. So these are actually speeds, which is not really a unit, but what you can do is set, or these have A cell, D cell, velocity, and maybe some other settings inside them, but these are predefined ones. So this is about 1 meter per second, which is decently fast. You don't want the robot to hit you at 1 meter per second. It's pretty quick. So we now have that path. That's the default. On a real robot, if you're going to do this, turn this way down, because if you accidentally make a point or you modify one of these, it's going to put it at 1,000 and it's going to give you trouble and you'll crash or something, and it's not good. So default these to something useful. Z here is find, means go to exactly this point as close as you can get and stop. And then these zones are, it's explained pretty well in the manual, but essentially what it is the robot's going to start moving. So if you're on this first point here, the zone basically is saying, but as it's going to point 30, we're trying to go from 10 to 30. So if you start at 10, it's going to go through to 20 because that's in its path. If we wanted to go straight to 30, we could just delete 20 and it would end up there. But we want to go through 20 here and make it to 30. Maybe there's something we want to avoid here or whatever. So this zone here is how close it's going to get to this point before it starts rounding off that corner. So it's only gonna come within like a V15, I believe. It's a 15 millimeter diameter of the sphere around that. I think. Check that in the manual for ABB. But either way, this is like Fanuc's conc. I want to say CONC option. But you're basically saying, how close do you really want to be to this point? Because if he goes to it and stops on it, and then he goes, we're going to waste all this time. But really, we want to just zoom right by this point. So essentially, if you set a high V, or a high Z value, rather, he'll just swoop by generally in the area. It'll go a lot closer here. So if we have a smaller number, Z15 seems pretty good for general robot pathing points, or that's what I do. And you start making it bigger if you have a lot of area around other objects and walls and stuff. You can really zoom through there to get your velocity up if you need to. But now that we have our path, we can actually tell the robot to run it, I believe. So let's synchronize this over to rapid. So this is it going to, it's saying basically send everything out. You know, how do you want to store them? Constants from targets is fine. Here's a module. You could put them in a separate module, but we'll use the default one. So now you wonder what happened to this data. How do you get to the virtual controller? I'm on the station now, so I can't actually see that code that it just generated. All of these, you know, I can come in here and do a modify instruction and change this sort of stuff. But I don't really like messing with it here. For one thing, when on my first big project, that was bugged and it didn't work. So I got used to not using it. But if you come over to the rapid tab, you can actually get you get new tabs here based on what tab is selected here, which is very odd to me. But you have a rapid program here. This is the task. This is the module we put it in. So a module is something like it's just a logical separator, so that you can, you know, if you have part A, B, C, D, you would have maybe module A, B, C, D, just to keep all your points and your paths just, you know, compartmentalized in these little areas and make sure that you can keep track of them all. So let's look at what it generated here. Module 1 is the module. Constant is just saying it's in memory, it won't change. It's not changeable on the fly at least. And then our target name, it's of type rob target, and you can look over it. This is like a structure in C++ or something. So you have the trans is the translation, ROT is the orientation, so the other 3 degrees. Config data we'll get into later, that's the robot's configuration. And then external joints, let's see, I'll do configurations next, but so then you have external joints would be if you had multiple axes. But anyway, so these targets here, you can see we have our points. So we, of course, messed with our 1,000, 1,000, 1,000 that I started with, but this is its world coordinates, X, Y, and Z. And then this is the quaternion of its rotation. That's how it stores it here. But I don't recommend you change these points here because, you know, what do these numbers really mean to you? They're based off the robot's base, which is pretty arbitrary. So we're going to leave them where we click them in the CAD world, and we'll worry about referencing them to objects later on. So here's our path, and it's just a move linear here, move linear to target 2, move linear to target 3. So let's see if we can run this now. So it's starting here. This gives me problems on the first try sometimes. Rapid symbol main in trob1 not found. Okay, so it's mad because we have an entry. We haven't really defined an entry point, and I think it's defaulted to main, the program, and so we have this module 1. So what we really need to do here is come in. Let's see, how do we do this? trob1, new module, main. Okay, see if this works. You open it up and grab 10. Come on, main. Module main. Path 10 is what we want to run in module main. Do I need come on. Oh, that's right. Module main, and then we need a proc main and proc. Do I need this on proc main? I can't recall. And then what does main do? It runs this. So now we have an entry point for our task. Take this off. Path 10. Apply. Yes. And module name main ambiguous. Main proc. Alright, so no errors. Everything's good. We're ready to move our first point. Uh-oh. So he said joint out of range. And so we've asked him to do this really odd thing here. And you can see, based on this orientation that I started with, that's no good. So I'm going to grab this target, make him, you know, something. God, this stuff is real buggy. Come on, buddy. Here, I'll do it this way instead for the sake of the video. So that would be about the y-axis, local. So I'll click Y. Just go the other way, -5 degrees, and I'll click him around. And then let's view the robot at the target. Make sure we can reach him. So that looks good. Click this other target and knock him around a bunch of degrees as well. But what I should do after that is go ahead and synchronize back to the station before I make any other changes. And so it completed, and now I have this main prog here. So I've got these sort of two systems that I have to fight to keep up to date. So it'll show you the actual program live here, which is nice, but I don't like that usually, so I'm going to turn off program pointers, or you can do go to motion, go to program pointer, and stuff like that. So we'll head back over here and play again. Now it won't steal our window focus like it did, and there we go. So I'm starting the move. He's going to the first point, he's going to the second point, he's going to the third point. What's odd about that is that he doesn't go back automatically. So we can do that either here. We can come back to Home tab, which brings us back to the station, and we can add another move at the end to target 10. Or we can come over to Rapid, which is where I prefer to do it. Open module, come here, grab this, paste that in, and now he's going to go there. Apply, yes. And what's weird is, we've applied that on the virtual controller, so now we should be able to just run it because you're actually running the virtual controller here. So, boom, he ran once, hit it again. He's going all the way back home. Everything's good. So, that actually is what you call a linear move. You saw here in Rapid probably, if I go back to the program. This is a move L instruction. I might get into this more later, but just want to note that a linear move is if you're doing something like you're milling a circle or you're milling a path in a part, and you've got to just cruise right along at a certain speed, and you want the robot to follow a path, or like say you're drilling a hole or anything like that, you need a linear move. Whereas you can also do a joint move. So I would come in here and make these move J. And what that does is basically says, I don't care what happens in between the 2 points. I just care that the robot gets there. And what it can do is actually, rather than creating a joint path for each of these joints and making the robot move gently across this line, or within a tight constraint of this line, it will actually just get the robot there. So let's play that now that we change those to joints and see what he does. So you can see he's swinging way wide. Let's keep him going. Let's put him in continuous here. So you can see he's not following the path at all, really. He's hitting this point. He's coming within a zone of this point, which we talked about earlier, and then he's coming near actually to a zone around this point as well because we're coming back. So he's zoning each one of these points all the way around, and that'll get you the most speed out of the robot. And it also has some other tricks about getting across configurations and things like that, but that's out of the scope of this episode. So that's about it. This one went a little long, but I got a lot of stuff out of the way that I wanted to explain.